Hello everyone, welcome back. So today what we'll be trying to do is make the marching square algorithm, um, which here is the Wikipedia page for it. Basically, let's say you have a grid of points, and those points are weighted. Right now we'll just do weighted between like either 0 or 1, and based on 4 points that are on the, let's say you take, for every point you take the right point, the one point, which is diagonal bottom left, bottom right, the 1 0 point, which is the right one, and the 0 1 point, which is the bottom point, and you make, let's say, square with it. You can then select between 16 cases which line, where to draw a specific line. So given this this sheet, you can see it here, right? So let's say all the points around the 9 points in the middle are all 0, and all the 9 points in the middle are 1. We can then make a square for each of the points, right? And see where we draw the line for that square. So that's pretty much the algorithm. Let me go on the whiteboard and try to explain the process, right? So we'll have a grid of points. So let's say here, right? So we'll make a 2D grid that's going to be scaled based on scale value that we choose. A scale is just going to be the space between the point, for example. So let's say I have all of those points, right? Now what I need for all of the squares, so we'll have a grid which will be, let's say, a grid which will be a 2D array, right? And we'll use, I don't know, we could use squares. Sure. Yeah, sure. So we'll have a grid of squares. And we can make square into a class which will have a 4 values for the 4 corners, and it will have xy, which will be the top left corner point, and then it'll have the scale also provided, so that we can know where is the middle here, middle here, middle here, and middle here for each square. Let's say this would be for one specific square. And then based on the weight of the 4 points around it, we can determine which lines to draw, right? This line, this line, this line, this line, or like that, right? And then how much of those we do want to use. So I'm thinking we have the square class, right? So class square, which would contain, so we said the four values we want for it. So we'll do, let me think about it. So we'll do, we'll have, we could just have an array of values, right? So we'll have values be equal an array of 4 values, which will either be 0 or 1, right? Something like this. And this array will say this is top left, top right, bottom left, and bottom right. Okay, so this is how it's going to go. This is top left. There we go. So this will be the value. We'll have an x, which will be just a number. And this will not be exactly x. Well, I guess we could pass x. Sure, we'll pass. Sure, yeah, that's fine. We'll pass x, and we'll pass y as well, which will also be a number. And we will have a scale. We'll call it SCL, just so it's easier. It'll also be a number. So the scale is basically this length, right? So the length of one side of the square. Then we can have a method for, whoa, sorry. we can have a method for drawing the line. So we could have a method called, let's use, what name? We could use just some, let's use show. Sure. Or we might want to also in here have, in the constructor, so we could have something like lines, right? And lines would just be an array of let's say arrays, which would contain vertex and vertex for one given line, and we can calculate which line we want in the constructor. We could have we could call a method called something like calculate lines or just calculate, and then we could have a function for showing, right? So show lines or just show, which would just loop over lines. So, and just draw the lines using our lines, right? So that's what I'm thinking. And the big method will be calculate. Calculate will be basically just we'll basically do like something like if else or switch case, regardless, it doesn't really matter. But we'll basically have cases where like for each of the 16 possibilities, right? So that's pretty much it. So let's try to get that working in the code. Let me switch this. There we go. Just okay, great. So over here, I have a square file which doesn't have anything. We'll have the square class in here, right? So we'll have class square. Like we said, we want a constructor which will receive a couple of arguments. It'll receive x, y. It'll receive its values. What else? We want the scale. That's pretty much it for the moment, I believe. So yeah, that's fine. So we'll have this dot x equals x, this dot y equals y, this dot values equal values, and this dot scale equals the scale. There we go. Great. So now let's make the calculate method, and we could call this afterwards. It doesn't need to be called right away. So we'll have calculate, and we'll also initialize in the constructor the lines as being just an array, an empty array, and we'll add to the lines based on the calculate method, right? So here we want to know which case we're in, right? So let's say, so here we have all of the case. Let me open this up in a new tab. There we go. Let me zoom. There we go. All right. So we have all of the case here. Let me zoom down. Okay, there you go. You're not able to see. Let me see. Okay, that's fine. So let's say that the empty circles are just value being 0, and the filled ones are just value being 1, right? So we could have an like, let's say we'll create like const top left, which will be equal to this dot, just so that it's easier to work with it. This dot values index 0, and we're expecting values to always be an array of length 4. So we'll have const top right, which will be this dot values index 1, and same thing for the bottom two vertices. So the bottom two values. So bottom right. So we'll go like in clockwise order, starting from the top left. So bottom right value will be this dot values index 2, and the last one will be the bottom left value, which will be this dot values index 3. There we go. So now we could do something like if, oh, and possibly we could just make this, I'm just thinking, no, it's fine. I think I want to keep it as values because later on we might want to do the interpolation between the two. So that's fine. So let's say here, so let's start with the first case, the case 0. So let me comment this, or let me put the comment over here, right? So let me do this, let me here, okay. Case 0, and we're basing ourselves on the Wikipedia page. So whenever top left equals 0, and now we can just do all of this. This is definitely not the most effective way to do it, but for right now, we'll be doing it like this. Maybe later on I'll change it, but for right now, I just want to get something working, right? So we'll do it like this for the moment. And we can say like, we could have a function like just a quick function, easy here, right? Or we don't even need this because let's say we could just convert all of these to true or false, right? So let's say this, right? So not will convert the 0 to true to false and the rest. So whenever we're not top left and not top right and not bottom left, bottom right, and because I'm just doing it in the same order, and not bottom left. Yes, okay, there we go. So this is the case 0. Now we'll do else if, and we will just copy this over here, and I'm just thinking yeah, let's do it just the dumb way for right now, just the way that is easier to understand, but afterwards we might want to do some refactoring. So this is case 1. Okay, there we go. So case 1 is just the last one that is true, so bottom left. Let's now copy this whole thing. There we go, a couple of times. Okay, so we've got the case 1. Case 2 now, it's this one is false, and this one is true. Bottom right is true. Now case, this one is case 2. So next one, case 3. We have the 2 bottom ones true. Case 4 is going to be the top right one. Okay, there we go. Case 5 is going to be top right and bottom left. So bottom left and top right. Here, bottom left, top right. Case 6, it's going to be both on the right side, so bottom right and top right. There we go. Case 7, it's going to be all 3 apart from the first one. There we go. Okay, now case 8. I didn't skip any of them. No, I think that's good. Okay, case 8, it's going to be only the first one. There you go. Let's copy this a couple more times. So case 8, case 9, which is going to be both left ones, so bottom left and top left, that's good. Now case 10, it's going to be top left and bottom right. There we go. Now case 11, it's going to be only not top right, so the rest is true. There you go. Let's paste this a couple more times. Case 12, case 13, case 14, case 15. Okay, case 12, which we didn't do, which is the 2 top ones are true. and the bottom ones are false. There we go. Case 13, all of them are true apart from the bottom right one. So all of them are true apart from bottom right. There we go. Case 14, all of them apart from bottom left. So, right, yeah. So apart from bottom left, I said, yeah. So case 14, yeah. Apart from bottom left, all of them are true. Let's just do this. Case 15 now, all of them are true. Okay. There are definitely ways to make this a lot better, a lot faster. Just hear me out. For right now, we'll just do it like this, and we'll see where we're at later on. I think I messed something up because I don't think. Okay, case 8. Let's just review them. So case 0, all of them, none of them are true. Then case 1, only bottom left. Okay, it's good. Case 2, only bottom right. Yep. Case 3, only bottom left, bottom right. Yep, that makes sense. Case 4, only top right is true. Yep. Case 5, top right and bottom right. Top right. And bottom, top left, sorry, case 5. Top left is false. Oh yeah, never mind, sorry. Yeah, bottom left and top right for case 5. Bottom left and top right, that's good. Case 6, both on the sides, so right, everything is right, yep. Case 7, everything apart from the first one, that's correct. Case 8 should be nothing apart from the top left, and you know what? Case 8 and case 7 are the same, so what I'm going to do is just remove this, and we'll do here and case 8, and we can just remove case 8 because case 7, case 8, it's both the same condition. I don't want to remove this. I want to do basically an OR on all of this. So we'll make all of this into a parentheses, and we'll do OR all of this is true. There we go. Is this? Yeah, this is to be removed. Now case 9. Case 9, I think we already have it as case 6. So let's do the same. Case 6. Let's do this. Or that. There we go. So we'll do end case 9, right? Yep, that's correct. Okay, let me go here. Let me remove case 9. Oh. Okay, case 10, is it the same as another one? I don't think so, that's a new one. Let's do it. So case 10, it's going to be top left, okay. Top right, no. Bottom right, yes. Bottom left, no. Okay, that's right. Was I looking at it right? Yeah, okay. Now case 11. Case 11 is the same as case 4. So let me move this into the same as case 4 over here. Case 4 and case, I said 11. There we go. So let me remove 11. There we go. Case 12, it's the same as case 3. So case 12, same as case 3. Or this, which is in case, I said case 12, right? Yep. Okay, case 13, it's the same, I believe, as case 2. There you go. So case 12, we said we could remove. Case 13, same as case 2. Yep. Case 2 over here. Same as case 13. Case 14, same as case 1. case 14, same as case 1. And case 1, no, sorry, 14. There we go. So me remove the case 14. Awesome. Now case 15, it's we'll leave it alone. Okay, and I didn't check the one I just moved. So case 14, top only bottom left. Yeah, that's right. Case 13, only bottom right. That's good. Case 12, on both bottom. Yep. Case 11, only top right. Yep, okay, that makes sense. Did I check for case 9? Case 9, let me make sure. It's supposed to be both right or false, yep. And then case 8, which is only top left is true. Okay, yeah, that's good. Okay, in case 15, all of them is true, which is the same as case 0. So we'll just move this to case 0 as well. So here, and or here, same as case we said 15. There you go. Okay, so case 5, let's just make sure it's a unique one. It does seem like it is. That's good. And the other one is case 10. So both of them, which are like this. That's good. The rest, it's all same as another one. Okay, so now let's make the lines, right? So let's do const. Let me make like all of these sides vertex. So we have the top, which will be create. If I can type vector, and we'll just copy this 4 times. Well, 3 times. Top. We'll do right, bottom, and left. Okay. So top will be x plus this dot scale divided by 2, and the y should be 0, or y actually. Now right should be x plus this dot scale, comma y plus this dot scale divided by 2, and it's not just y and just x, it's this dot. I always forget it. Not used to putting it everywhere, but there we go. Okay, now the bottom, it should be this dot x. It should be the same as this for the x, and the y, there we go, and the y should just be this dot y plus this dot scale. Okay, and the left one should be for the y, it should be pretty much like this one, and we'll use this dot x since it's like 0. Okay, right? Does that make sense? I think it does. Sure, we'll see. Okay, and then we can just do this dot lines dot push. Yeah, sure, that's fine. And we can push new lines into here, right? Whoa. The only ones that are going to have multiple lines are going to be the case 5 and 10, which we have alone. So here we'll have 2 lines, 1 line, 1 line, and 2 lines. Okay, there we go. So now we just need to add the 2 vertices for the given lines. So we'll put that in an array. So we'll have first vertex for case 0, we don't have anything. So we'll just leave it alone. We don't have anything. We'll keep the if just because, but technically it doesn't need to be there. So line case 1. Case 1 should be a line between the left and the bottom. There we go. Now here, let me just put my arrays everywhere. so that it's easier when it comes to this. Okay, there. Okay, wait, I'm missing one. Okay, there you go. So, okay, so this is case 2. Case 2 should be bottom and right. Okay, great. Case 3, I guess. Yeah, case 3 should be between left and right. Oh, and this is left and bottom. Yeah, that's right. And this is, yeah, okay. So left and right. Now case 4 should be top and right. Okay. Now this one, it should be between top and left, and it should be between bottom and right. Yep. Top left, yep. Bottom right, yep, that's right. So case 6, right? Yep. So, case 6 should be between top and bottom. Top and bottom, there we go. Case 7, it should be between left and top. Left and top. Okay, there we go. And case 10, it should be between bottom and left, and also between top and right. There we go. So we have all of our lines now created, and we don't have any lines for the case 0, case 15. So that's good. All right, I think we're pretty much close to this. Now what we can do is just create a show function, which just draw lines based on the lines that we have. So we can have a for loop that goes between, well, that doesn't, we can use for off loop. Should we just make sure it's recording? 27 minutes we're at, that's fine. So we'll have L for the lines of this dot lines. Okay, great. And sorry for the sound, let me mute it. There we go, that's good. Yeah, okay. And then we'll just do a line that goes between L index 0 dot x and L index 0 dot y and L index 1 dot x and L index 1 dot y. There we go. So we have our lines, we have our square. Let me get back to this. So now let's create the grid. So we'll have like a variable for the grid, or the board, whatever you want to call it, grid. And I'll want also a variable for the values, just because I'm going to create the value and then the values and then create the grid. And we'll have a variable for the scale. Whoa, God, no, didn't meant that. There we go. We'll have, let's say, scale of, let's say 50 for the moment. And okay, so now we can check how many columns and rows we have. So const columns, and we'll base this on the width of the canvas. DTH, yeah, divided by config dot scale, and const rows equal to height divided by config dot scale. Okay, great. Now we'll do the values first. So we'll have for let x be equal to 0, x is less than the calls, calls x plus plus, and for let y is equal to 0, y is less than the rows, y plus plus. There we go. Awesome. We'll create here, we'll say that values index x is equal to an array, and that values index x index y is equal to the result of noise. And we'll do yeah, sure, okay, I'll see. So we'll do noise, and we'll pass an x offset and a y offset. Okay, great. And we'll say if that value is greater than, let's say, 0.5, we'll set that to 1, otherwise we'll set that to 0. Sure. And now we'll just need to create the x off and y off. So we'll have let x off be equal to, let's say, 0, and let y offset be equal to also 0. That's fine. Here we'll do y offset plus equals 0 point some amount, right? So let's do this for right now. We'll see how smooth it is, how we want it to change. And x off plus equal a different value, otherwise we'll kind of see just like a line. And 0.01, sure, that's fine. Okay, so now let's do basically the same loop, but for our grid. So we don't need the offsets since we already have calculated values, and here it won't be values, it'll be grid. I think I called it grid. Yes, okay. And now grid index x, index y should be equal to mu square, passing it its x, y, and xy needs to be the actual xy, so we'll need to multiply by the scale. Multiply, I said, there you go, by the scale. Multiply by the scale, there you go. And afterwards it was, what else? The scale itself and values. Sorry for your ears. Didn't mean that. The values, sure. So the values will have an array called, I'll call it V, just because otherwise it won't work. Okay, because we already have values defined. So we'll have values index x, index y as the first value always. Then the second values should be, and we'll say something like if, sure, give me a sec. So we'll say like we'll have like 4 different values. So we'll have like const current equals the values at x, at y, and then we'll have const top left instead, top left, top right, and here we'll say if top right should just be basically this, but x plus 1, but we'll say if x plus 1, this is only valid if x plus 1 is smaller than the cols, and if it is, then we can use that, otherwise it'll be 0, sure. Then we'll do basically same kind of stuff, but for so this one's this plus and this plus, otherwise it's 0. So here we'll need bottom right will be if x plus 1 is less than cols, and y plus 1 is less than rows. There we go. Otherwise it'll be 0. And then bottom left, it's going to be, this is going to be 0, so it doesn't matter. So it'll be y plus 1 is less than rows. There we go. We'll move this plus over here. There we go. Okay, I think we're good. So we'll have here at the end the values. It'll be top left, top right, bottom left. There we go. I'll put this on multiple lines just so that it's easier to see. So x, y can be on the same line. There we go. Okay, there we go. And now what I want to do is also initialize the square, meaning calculating it. Calculate, there we go. Okay, and now we could possibly just call show right away, which I'm fine with. So right now it's going to be static for sure, but for right now let's do show. Let's say background it's black. Let's say the stroke is 255, and let's say the stroke weight is 3 or something, right? Let's say no fill. I know we're not drawing any shape, but doesn't matter. No fill. There we go. And now let's try running this. So let me open up this. This I don't care. Let's update it and let's click go live. There we go. Okay, so I think we have an issue over here, right? If I refresh, we're only seeing it white. So what is the problem? Cannot set properties of undefined. Setting is 0. All right, let's take a look. So here, grid index x is equal. Oh, you know what? I need to initialize both of those to empty arrays. Okay, so we've got further. Square is not defined. That makes sense because I haven't referenced the file. So let me reference it. Square. There we go. Oh, I removed. Oh, no, it was fine. Square. There we go. Okay. So it seems like it's not drawing it properly, right? Or it's not calculating it properly. So let me see. Let me refresh this. Oh, it seemed like we did have something at some point. Let me refresh. So we have a couple of lines. Okay, so what's happening now? We can possibly just display the values, right? We could just do something like let's say fill 255, say 200, or based on this value here. Okay, so we'll say based on the value of the noise, we'll call this 0.5. Maybe I don't want to use this. Maybe I want to see. Well, let me think. If I did random, there we go. So now we're using random values, but which we're seeing it's currently working, right? Because if I were to show the points, let me just do a point instead. We'll do point at index at xy. There we go. Why are we not seeing the points? Let me think. Stroke 255, stroke weight. Oh yeah, point time the scale times config.scale and times config.scale. There we go. So now we're able to see the point, and we can do something like the stroke to be equal to, let's say here, let me take this, let me set like value. There we go, and we can say, and random returns us value between 0 and 1. So that's why we want to clamp it to either 1 or 0, like to force it to be either 1 or 0. So here we can say the stroke is 255, and we can multiply this value by 255 for the alpha. There you go. Now we can see the basic schema, and if I were to use noise here, like we were previously, noise, and let me do, never mind, let me do also here, stroke, just set it back to 255 whenever we're done, so that the lines are actually 255. And let me do stroke weight here, let me do stroke weight of like 5 or something, and then put it back to 3 afterwards. So over here, there we go, 3, that's good. Okay, maybe even 2. I don't think it needs to be that thick, even 1. Yeah, sure, that's fine. There we go. So every time refresh, you can see that the shapes that are being drawn are using what we defined in our square class. Great, I wasn't sure I was going to get it the first time on, but it seems like we did. So one thing though is I want to see here, right? If I were, because we were using noise, but I think it's just the threshold value I was using, which was 0.5, wasn't too good. So let's use noise x off and y off. Let's see visually the points. So it's pretty dark, so we might want to do like 0.35, right? Anything that the value is greater than 0.35. You know what? The scale may be a bit too much, so let's do this. Let me do even more. Okay, move this a little bit bigger. Okay, so that's good. And we can use this. We can use the noise detail function to get different type of noise. I believe my goal is to have, like, let's say 10 and 0.3, right? No, more, 0.6. No, 0.3, I think, and more of this. Let's say 20, 25, 30. I want like a bigger map or smaller. I don't know what to say. Let's change the scale. Now we can see it. That's good. And let's put this back to, like, let's say 10. Okay, maybe 15 could be good. And let's do here 0.2, 0.1. Okay, sure. So every time we refresh, we get a different shape based on the noise value. And we can do, like, let's say an average of all of the values to get the actual 1 or 0 over here, right? So I could actually store just the value and afterwards just do that. So here we did 0.1, and I might even want, like, let's say 0.3. Oh god, okay. And let's do here like 2, 3. I don't know exactly how it modifies it, but it does seem to change it. So if we were to make this full screen, nope, didn't meant to save this. Okay, there we go. So now we get some different results. So that's looking pretty good to me. So one thing we could do is, let me move this back over to here. Okay, great. Let me refresh. Okay. So one thing we could do, I haven't thought about lerping the values, that's for sure, right? So instead of, like, looking at 1 or 0, it would basically, let me go on the whiteboard and try to figure this out, right? So right now we're using only 1 and 0s for the values of each point. But let me erase a little bit of what we have on the whiteboard, just to make myself some space. So this we're pretty much done with. We might want to update this later on, but for right now, that's fine. Okay, great. So we know, yeah, it's a bit wet still. Give me a second. There you go. Okay, I think that, yeah, that seems fine. So we know one square is made of 4 weighted points, right? And currently they're weighted between 2 values, either 1 or 0s. And that's how we determine where to make the segments. But let's say we wanted like 0.5, a value that goes between 0 and 1. So let's say here 0.3, here it's 1, here it's 0.3, right? I'm thinking, could we just figure out the lerp value between those two? Well, no. Let me think. So, oh, right. No, wait. Just trying to figure it out. We're at 0.5 out of, never mind. I'll be right back after I've thought a little bit on this. All right, I'm back. Sorry. So, okay. So we erase this. I think I got it. We'll see whenever we implement it, but, oh, okay, there. So we have, like we said, our 4 vertices. And right now the only possible value for those vertices are 0 or 1, right? But we want to take a value randomly between 0 and 1, right? So we can have 0, 0.3 up to 1, right? So any floating point between 0 and 1, including 0 and 1. We'll still have our threshold. Let's say the threshold is, I believe currently we have a 0.3 threshold on if we do have it or not for the value rate. Like right now we're doing like noise and if noise is greater than 0.3, so that would be, let's say, our threshold. So let's say the threshold is 0.3. So we'll call this t, right? So t equals 0.3, 0.3, or let's say 5. It doesn't matter. So the threshold is 0.5. We'll keep the same principle than what we currently have for the values. The only thing is that we're also going to keep the original value of this, right? So we'll have, if the value that we have is smaller than the threshold value, then we make it as 0, and otherwise we make it as 1, but we'll still keep those values, right? Or we can actually just use the threshold whenever calculating the squares. Yeah, I think we'll do that instead. Well, it might be more demanding, but I think it's fine. I think it doesn't matter for the sake of the example. So let's say this one is I'll say true. So meaning value is greater than 0.5. So let's say 0.7, and here it's let's say 0.5, right? Let's say including 0.5. Here, let's say the value is 0.7, and here it's 0.3, right? So this one we don't care about. We don't need to lerp it with any other ones. The only ones we want to lerp in the end, let's say this was 1 and zeros. This would be 1, this would be 1, this would be 1, right? So we would technically make a line here, right? But now we have this. So we know we want to lerp between these two and these two, right? So what we can do is to get where we're at here, where we're on this line, whenever we do make the line, because 0.7, 0.7, it might look something like this, right? Or the other way around, like there's less over here. So instead of having it in the middle. So we can say, let's say for this one, 0.7, 0.3. So we can say, let's say the amount we want to lerp by, t for amount is equal to the map of the threshold t and both values that we have, right? So let's say in this case, let's say 0.7 and 0.3, and which goes between 0 and 1. We want to map it to something between 0 and 1. We want to remap it to 0 and 1. This would give us, let's say, in this case, t is 0.5, so we want to move to here and check 0.5 and then get the amount. And then we can lerp. So lerp, well, let me erase this, lerp. And this would be like, let's say, y to add to this y, lerp. The first x, the first y and the second y, so y1 and then y2, and then the amount that we want to lerp by. That's it. So I think that possibly should work. Let's see if we can get that working. I might not be able to get it working, but we'll see, right? So instead of getting something like this, blocky, we'll have something like this, more fluid, kind of. I don't even know, is there something on the Wikipedia page for regarding this? I'm not sure. Let me zoom out a little bit. Disassembling, saddle point, customizing, triangle mesh. No, it's fine. Apply linear interpolation along the boundaries of the cell to calculate the exact contour position. Okay. Pre-built lookup table, that's fine. Let's not care about this right now. Okay, so let me get back to this. So here we have calculate, right? So value index 0, 1, 2, and 3. And we'll say value will be will be value index 0. And we'll get back, so top left, right? So here, instead of create vector, we'll have to do something different. Sure, let me go back to the sketch. Let me do this. So value here, whenever we had this, we have all of these, which will be their own array. Or technically, we could just say, whenever we do create the values here, they are going to be values. This is fine. Over here, we'll say all of this will be its own thing, and then value will be here as well, right? This shouldn't have changed anything. Yeah, okay, it's still working. So now let's go back to the square. This is going to make my code look really bad. It's fine. It's fine. I removed the, well, let's keep it for right now. So here, top left, so let's do it only for 1 and 14, let's say. So 1 and 14, it's, let me get back to this image, right? So 1 and 14 is, so we'll look at 14. So 14 is the bottom left one, right? The one we were looking at, basically. So here, we want to do lerp. So we want the amount to lerp by, and we want, let's pass to calculate the threshold. Let's call it t, just like in the example, and we'll pass 0.35 as the threshold. So here we can have a value for the threshold. Threshold, is it like this? I don't know. Maybe I'm wrong. It's fine. Doesn't matter. Threshold. Okay. And we'll use config.threshold here. Okay. And over here, when we do calculate, we'll pass threshold, config.threshold. Okay, good. So now in the squares, we have t. All right. So we want a new vector const v1, and we'll have, oh, let me mute this. We'll have create vector, it's fine, and we'll have v2 for the 2 points, right? So right now it's between the left and bottom, like we can see over here, right? So just like in the example we did. So we want to lerp a given amount. So let's get that amount first thing. So we'll just copy, we'll just say basically, how do I want to do this? Let me do this, and let me put a v at the end for value, and it will basically be the index 1. Sure, that's fine. So we want const amount be equal to the map of the threshold, and the threshold will be between it's going to be top left value and bottom left value, right? Which we wanted to map between 0 and 1. This is for the first amount, correct? Yeah, I think so, because we'll want to lerp the other one as well. Okay, let's see. So here we want to lerp, we want to keep the x as the x, so this dot x. The y, it's going to be basically the left one, right? The y, it's going to be this dot y plus this dot y. We want the lerp value between this dot y and this dot y plus the scale, right? Okay, and then we want the amount. Okay, I think so, right? So we have the first vector, and now the second vector will create amount 1, and amount 2. So const we have the v1 and const amount 2. We're just trying to figure it out. Afterwards, we can make it better map between t, and we want the bottom left value and the bottom right value between 0 and 1, and then we want to create it at, in this case it'll be this.x. We want the lerp value, lerp, between this.x. Here it'll be this.y plus this.scale, and here it'll be this.x, and this, we want the lerp between this.x and this.x plus this.scale, right, at the amount 2, I think. Let's see. So let's do v1 and v2. v2, there you go. So let's see this. Okay, so we have the so we have some gaps, right? Let me think. It's going across. What is the issue here, right? Let's do random values as well, just so it's easier to see instead of noise. So let me comment out noise. Let me do random like this, and let me do config the threshold to be 0.5. Okay, there you go. So let me make the scale even bigger, just so that it's easier to differentiate. Okay, good. So, and let me do also here, not value, but this value, right? This index 0. Okay, sure, it's good. Okay, so for example here, right? This is 0 or not, right? It's some value. X is there. Why don't we have the line created? Let's console log v1, v2. Let's see here. X 700, y minus infinity. Okay, minus infinity. That's a problem. Okay. Why is that? Minus infinity on the y for the first one. So this one, right? So this one, it's basically plus scale by amount. Let me take a look at amount. Okay, let's see. Let's say this first one, minus infinity and 0.5. So the first amount is bad, really bad. So top left value, bottom left value. That makes sense, right? You know what? Let me remove the case 14 and see. Never mind, sorry. Let's see here, right? Because it's doing them. Let's take this one, right? Or well, no, not this one. Sure, let's take this one, right? So only the bottom left is true, top one is false, this one's false, so all of them are false apart from the bottom left. So then it's not showing. But when we have let me see here. Do we have a point where that would be doing it? Okay, so we have the issue for both of them. So why is it minus infinity? That's the question, right? So threshold's fine. Let me console log all of the values. So here, the amount, and then all of this. So, wait, what? Let me do this in a separate console log. Okay. So, oh, wait. Those two are true. Oh, well, that makes sense. Now that's, oh, you know what? There you go. This is the issue. This is the issue. Okay, there we go. Let's remove that. Let's see. Okay, so I think it's doing what we want, apart when it's not a number. What is the issue here? So not a number is provided by by amount2. Yes, amount2 is giving us not a number. And why is that the case, right? Because we have 0.5, because I think the rest seems to be working. The only thing here is, you see here, for example, oh, this is only, okay, let me take a look at the other values just to see. So here we have, let's say, mt1 and console.log mt2. Let me remove this and put it, there you go. Okay, so let's see. So, oh, you know what? When it's 0, it's actually multiplying by 0, so it's going to the left. What I want to do instead of getting this, I want to make it so that there's one more call and row than the actual size that we're seeing. Oh, but then the last one are going to do this. Let me do up to row -1 and call here -1. This should fix our issue. Okay, there you go. And then I should also be able to just remove this, I believe, hopefully. Let me remove, right, because we've added one row and one column. There you go. Okay. I think this could be right. So let's try it for the rest. So we know this is how to do it. So we could possibly create a function, static function called, let's say, lerp. Sure, lerp. It will need the threshold, 2 values, v1, 2 values, yeah, v1, v2, and I don't want it to return just the amount, so we'll do that lerps let's pass it 2 values, or yeah, I mean, it could just return the amount. That's fine by me. Sure. Well, it's going to be a bit more code for the rest, but it's fine. So we'll remove this, and we'll return here. We'll do return this, which is going to be t v1 v2. Okay, I mean, it's going to be repetitive, but it's fine. You can make it better for sure. And I'll do this is not going to be pretty, but I'll do something like I want another top left, top right. All right, sorry, I just stopped the recording starting back because we were getting really it was getting really long. Hopefully I think of editing it, and right now this is just a cut that you're seeing, that it wasn't too long, but I've done pretty much what I said I would do. Did it for all of them. Noticed some errors in a couple of them, so I redid it, but just put them at the top, so I didn't have to redo all of the calculation for every one of them. I'm just calculating once for all of them and just using the ones I need. Much less confusion like this, right? So seems to be working. So right now what I want to do is basically put back the noise value that we had earlier and change back the threshold to 0.3, let's say. And now, or 0.35, something like this, right? Let's see. There we go. So now we can see it's a lot more smooth. Let me put a smaller scale, maybe 10, right? Just so you can see. So you see it's a lot smoother whenever we're going across the lines. So we're basically lerping between both lines, right? So let me do maybe just index 1 modulus. There we go. So now we can see a little bit better, but it's a lot smoother. The lines that we're drawing are a lot smoother than previously, right? This was the whole goal. I know it took a bit of time, but we got there in the end. You can implement this with a lot of different algorithms. For example, this is just some noise value making a map, right? You can make a map for a game like this, possibly. I'm just using it right now, but let me comment back this noise stuff. Okay, there we go. So, and let me maybe make this a little bit smoother, maybe 0.1 and 0.1, right? There we go. So, and let's maybe start at some random offset, so random between 0 and 100, let's say, or 190, it doesn't matter. So let me also make the spacing a bit more. There we go. Well, let me put it back to 1. So, and let me add back the noise detail, and let me take a look on the P5 website for some good values of noise. So noise detail, sorry, noise detail. Let's take a look, noise detail, awesome. So let's see, which one do I like best? The one on the right, I think. So the one on the right, I guess it's going to be this one, noise detail 4 and 0.5. Let's try that. So 4 and 0.5. Let's take it back here. There we go. So you can see now that we have our kind of our map pretty much looking good. The lines that we're drawing are pretty smooth. So this is the whole marching square. This is definitely not the best code you've seen. I would invite you to make a better version of this. Maybe having everything in square is not the best idea, for sure. It's definitely not the best idea, but like I said, really invite you to make yours so that it's faster, better than mine, which I'm sure it will. But this is the crude implementation for it. At least you can get something up on the screen that is working. And you can make this work with the just random noise, or you could try also using, for example, metaballs to make it look good, right? So let me just do this. So this would just be the marching square algorithm using the interpolation, right? And this is the scale basically. So let's say 10, right? Refreshing. There we go. So now it's even smoother. So yeah, I would really invite you to make yours. Try changing this, using this for a different algorithm you want, or a different visual you want to do. But yeah, hopefully you like the video. I'll be linking down as well in the description down below the Wikipedia page for marching squares. I will also be linking in the description down below this awesome page from Jamie Wong, and a video from Daniel Schiffman, the coding train, and also a video from regarding marching cubes from Sebastian Lag from YouTube. So that's pretty much it for today. Again, let me know in comments down below if there's anything you'd like to see, or share with me whatever you've done with this. It would be awesome to see. So yeah, that's pretty much it. Thanks for watching. See you in the next video. Bye.